माइक देगा
with my team members Abhishek Kumar, Bhaskar Mandal and Pradeep Sarkar from Haldia Institute of Technology, Haldia, West Bengal are pleased to present before you the paper presentation on the topic Alternative Construction Material Used for Removal of Methylene Blue from Aqueous Solution. The basic requirement for every human being is clean and non-polluted water. The wastewater from various sources such that of industries, domestic and agriculture are acting as a pollutant which is hazardous to human health, terrestrials and aquatic ecosystem. Dyes are one of them. We know what a dye is. It's a substance that is used to impart color to something like that of our clothes, the plastics we use, the colorful cotton we use, etc. Among them, we have methylene blue. It's a cationic dye, which is used in various industries such that of dyeing cotton, plastic, textile, automotive, and many more. But the presence of dye pigments in water stops light from passing through it, which reduces the effectiveness of photosynthesis and also causes microtoxicity in aquatic reagents and possess harmful effect on human health, like causing kidney malfunction, nausea, tumors, asthma, and many more. Hence, the most significant environment concern at the moment is reducing organic hazardous waste such as dye. Now, the question is how to overcome this problem. For that, we have a variety of techniques from the recent researches for the elimination of refractory pollutants from water. Here we have the chemical precipitation process produces more amount of sludge which is difficult to remove. The advanced oxidation process is a very costly process. Then the reverse osmosis process requires more amount of labor. Chemical oxidation process requires more amount of chemicals and also high cost machineries. Biological process is only effective when the solid concentration is low. Out of all these processes, adsorption process has been suited for the most reliable and effective process. Most commonly used adsorbents are, these are quite expensive. Hence, we have some cheaper alternatives such as clay, perlite, fly ash and geopolymer. For our present research work, we have used red sandy soil based alkali activated binder which is an absorbent at a very low cost. Now, I would like to call my teammate Pradeep Sarkar to talk about the next slide. Over to you.
Thank you so much. Now I would like to dive deeper and discuss the materials and method of removal of methylene blue from the aqueous solution. In adsorption process, we need an adsorbent and an adsorbent. For making the adsorbent, at first we dilute the red sandy soil and cement for 2 minutes. After mixing it well, we have added sodium hydroxide and sodium silicate in it and mixed it for another 5 minutes. Then we place it in 70.6 mm cube mold and rest for 24 hours. After 24 hours of casting, we demold the specimen and cure it for 7 days at an ambient temperature. Then we have cast the specimen into a powder form and sieved with the different size of sieve 150 micron, 300 micron and 600 micron. Before going to the detailed procedure of removal of methylene blue, let's discuss about the calibration curve. Basically, the calibration curve is made with the data of the spectrophotometer. Now, let us have a look on the graph. It is the absorbance versus concentration curve for the methylene blue concentration of 0 to 12 mg per liter. From the spectrophotometer data, we can get the straight line whose equation is y is equal to 0.1657x plus 0.0098, where y represents the absorbance and x is the concentration. From this equation, we can find the concentration of methylene blue of the different amount of adsorbent dose. Now the procedure of removing of methylene blue from the aqueous solution. At first, we make a methylene blue solution with the help of distilled water at a temperature of 27 plus minus 5 degrees centigrade. Then we mix the seed material and methylene blue in a mechanical shaker with a speed of 150 rpm. There are some parameters which affect the adsorption. The size of the adsorbent should be in between 150 to 600 micron and the adsorbent dose should be in between 1 to 12 gram per liter and the contact time should be in between 0 to 300 minutes. And also the temperature should be in between 70 to 37 degrees centigrade with an agitation speed of 90 to 200 rpm. After mixing the sample in each case, we collect the sample and analysis sample. From the analysis, we can get the amount of absorption by this equation C naught minus Ct by C naught into 100, where C naught is the initial concentration of methylene blue and the Ct is the concentration of methylene blue after any time t. Now the next portion of this PPT will discuss the maximum and master movement. Over to you, Mr.
Thank you, Pradeep. Now I want to discuss about some factors affecting the experiment. First one, the effect of particle size. In order to study the impact, three distinct particle sizes, 150 micron, 300 micron, and 600 microns were used, where initial methylene blue concentration was 50 mg per liter, is reduced from 29 and 3 gram per liter of absorbent. From the results, we can see 150 micron particle size having the greatest of more than 80% of efficiency, while 300 micron and 600 microns having 55% and 30% effective efficiency respectively. This is because the smaller size particles having much more effective surface area than the larger size particles. The next one, the